Hello, I'll be talking about running multi-arc clusters. This example is about MariaDB. So it's going to talk about how I built MariaDB, how it evolved from going from x86 and now having a mixed environment with Power, Little Endian and Big Endian. And then I'll be talking about some other self-healing stuff that I added on the presentation also. So yes, who am I? I'm from Belgium, so not that far away. Self-employed, I run a data center and a cloud. I'm involved with a bunch of Linux stuff. I organize some conferences also. Yeah, I have a Twitter handle and a blog, which I don't update that often. So, some history. MySQL. MySQL was started in 1995 by Monty. It was then acquired by Sun Microsystems, where it actually was ported to multiple architectures, and more recently bought by Oracle. The current version is MySQL 8.0, which is completely open source. It isn't the same. Well, it's not exactly what I'm going to be talking about, but this is where it originates from. You have the MariaDB, which is basically a fork from MySQL. So Monty did not like the idea of being bought by Oracle and therefore forked his code. Initially, the idea was to be fully compatible with MySQL. And for, I think, about 2 years, 2.5 years, that was actually the case. But afterwards, it actually changed a lot of their internal stuff. So it's not anymore fully compatible. It's still compatible with the API, but it's not like you can migrate your data directories anymore. Because of the fact that it was bought by Oracle, a lot of the Linux distributions migrated from MySQL to MariaDB. So you'll see a lot of the Linux distributions actually ship MariaDB by default in place of MySQL. Now, to be able to have a clustering system, there is another project which is called Galera. It's backed by the Codership. They started in 2007, and they are actually the multi-master replication system. That means that you can actually have more than 2 masters. So traditional MySQL replication was 2 masters and then a bunch of slaves. In this, you can have actually any number of masters. Typically, you choose uneven numbers so that you have quorum. That's not necessarily a requirement, but that's what they recommend. The other more important and more interesting part about this is that they actually do automatic node provisioning. So they have something which they call IST and STT, which is the initial state transfer, or a partial state transfer. But the initial state transfer means that you can boot up any Linux machine, point it to the cluster, and as long as it knows the cluster password or the cluster credentials, it will actually get all the data and do all the provisioning automatically. It theoretically integrates with all MySQL forks. So Percona, which is another provider, they have the Percona DB cluster, which is also using Galera in the backend. They use a principle called totem, which is basically full replication. It means that all master nodes need to acknowledge that the data has been written and committed before they actually continue, which means that if you have a 5-node cluster, a 5-node master cluster, all 5 nodes must acknowledge that they have written the data and committed it before they will go to the next transaction, which is a difference with Paxos, which is what Oracle decided to implement in their MySQL. So if you choose MySQL group replication, as it's officially called, they use Paxos, and as long as the majority of the masters has agreed, it will continue even if all masters haven't agreed. So it's direct consistency versus eventual consistency, which is why Galera is more popular because you know that everything has been written to all the nodes. So the setup we are discussing here is basically an e-commerce application. The front end is written in PHP. There's a whole bunch of middleware in Python and in Ruby, and there's a whole bunch of back-end work like price calculations, stock calculations, which is done in C. And then there were a few other projects. So the main project I'll be discussing is the e-commerce platform, but we did the same thing for Matomo, which is a Google Analytic on-prem open source version, an ad server, and request tracker, which is an issue tracking service. So when we started originally, it was, of course, one server. It's very easy to manage. At the time, there was no real clustering system, so the original MySQL versions had very limited access. It was a lot of manual scripts, but we were able to set up a small e-commerce website and deliver something up already to the customer. But of course, with one hardware box, if you need to reboot, if anything goes wrong, you're basically down. Now, remember, this is the year 2000. At that time, it wasn't very big problematic when you go down. I mean, e-commerce wasn't that prevalent as today. 3 years later, we finally were able to do multi-master. So if one of the masters rebooted, actually the whole website didn't go down. But it still required a lot of manual scripting. You had to understand the ID patterns. So typically, if you do any auto-incremental, you needed to have all the IDs set properly. You needed to have a configuration, which was a lot of manual work. This is still before most of us were using automation tools. So it was a little bit better, but we were not yet there. A few years later, we actually migrated to MySQL 5, where we actually had two separate individual cluster nodes. And we were able to split up the front end, back end, and be able to run multi-master in a more easier fashion. That was mostly playing with log positioning, so you could actually run your logs back and it would come up to date. You didn't have to manually do a restore and a dump to get back your second node. So there was some improvement, but still required manual labor. The next one is the one that actually does the fully automated deployment. So we had to move to InnoDB. Because the clustering systems only support transactional engines. So it meant that we were using rsync to do the state transfers, which meant that it was still a blocking issue, but it meant the machine would still come up, it would provision itself, and then it would be added to the cluster. During the provisioning, the machine or the host that would be giving the rsync would also be blocked, which is the reason why we went to a 3-node cluster. So typically, you would still survive if 1 or 2 would be out. We had to write, at the time, a custom as a Linux modules because they were not integrated at the time. It was running on CentOS 6, so it still had fairly good support. And it basically was just these few lines of configuration files that had to be added, which was fairly simple. You can script that in Ansible, in Puppet, in Chef, whichever one you wanted. You could template this, and it would come out, and your machine would do the automatic transfer, would initiate itself to the cluster, and everything would be quite easily set up. After that, we migrated to a version of MariaDB which actually had integrated Galera support. At this point, we migrated from rsync to Extra Backup, which is a tool which can actually do online backing up and restoring, which meant that you could do hot addition of nodes at a point. We didn't have to rewrite as a Linux policies anymore because they were upstreamed in the meanwhile. We still have a Galera policy, which is semi-upstream. There's some debate about what we are doing and what Galera wants. And we had a fully automated system using Ansible to set up all the machines, and everything was multi-master mode at that point. We had 3 hardware boxes. These were still running on x86 at the point, which basically meant that you had a setup like this, where the internet would connect to the servers, and you could have an outage of maximum 2 servers at a time, which also meant that rebooting was fairly easy. Everything was automated at that point. To have the state transfer, you could just put in the method, and it would actually do all the compression, the state transfer, and everything of that kind in there. Again, a few lines of configuration file, and Galera did all the magic in the background. The as a Linux policy was also not a lot of work. It basically is allowing the rsync to get access to the data and be able to connect to the files and the sockets, and was fairly easy to figure out. It came with CentOS 6, which has allowed to audit to allow, which basically generates or semi-generates all of these codes, and then you can manually edit them to your needs. So at this point, we wanted to do something with Power, but before we did that, we actually migrated to CentOS 7. At this point, we added SSL. We abstracted all the different machines. We used Ansible for orchestration, which meant that we have now a 3 web server cluster talking to the front end, a 5-node cluster running MariaDB, which was an integrated MariaDB. And it was running basically on 4 different physical machines. The next, so we added SSL encryption. That's both on the Galera part and on the MySQL part, so everything was secure at the point. So all communication, even within the data center, was encrypted. We moved to extra backup version 2, which could do even faster enablement and faster recoveries of nodes. And at this point, we actually migrated to Power. So in 2015, actually, we acquired 1 Power machine, and in 2016, the second one. We rebuilt CentOS, and it's actually now a distribution that you can find online, which is called PowerEL. It's basically a rebuild of CentOS with a whole bunch of patches and differences. So we don't run the CentOS kernel or the Red Hat kernel. We run a vanilla kernel of the Linux Foundation, basically. And initially, we started the Big Endian because that was the easiest to bootstrap. We did some optimization for caching because the Power machines have better caching systems. You have larger page sizes. It can actually do a whole bunch of checksums in the CPU, so you don't need to offset that to software. Hardware can do that for you. All patches were upstreamed through MariaDB, so they are all there in 10.1. I don't remember which minor version, but it was eventually added. So we were able to have 2 Power nodes running Big Endian and have everything running. So at this point, we finally had some Power systems, but we saw that having a full cluster only in Power wasn't what was best for our customers. We needed to have a mix and match. Also because certain of the calculations, like price calculations or stock calculations, run quicker on an x86. So we wanted to have the mix and the mixing possibilities. And that is after, so I think about a year ago, we finally went multi-arch. We have the cluster now set up with 2 x64 machines and 2 Power machines. the number of nodes in the cluster is still the same. It's just that we can run now workloads on specific machines depending where they run better. We had to switch to Little Endian to be more compatible with X machines, which is a recommendation which IBM told us to do, but in our tests, we actually tried running it with Big Endian, and it works pretty well. You can have some problems if you do some fancy stuff, but typically, till now, we have not had a lot of problems. So this is the point where we went actually multi-arch. And additionally to that, we added actually a newer layer, which is the monitoring and healing. So in monitoring, we need to know what is the current state of your cluster, what is the utilization, and what is the return value you get from it. So you need to know that your machine is running. You need to know that MariaDB is running as a process. But you also want to know that if you do a select, you actually get a value. So it's not just making sure that the process is running, but that it actually returns information that is useful. And with this, we can actually generate metrics, which is basically the same data, but over a period of time. And with this historical knowledge, we can then predict or use this to heal our system or make our system more robust if there is, for instance, a promotion coming up, or if we know that, for instance, for Black Friday, sales are higher, we need more machines. We can actually tell our orchestration system to do that for us. So we have hosts in there, which are bare metal machines. In this cluster, it's only 4 machines, so it's not that much. We have a whole bunch of virtual machines, which we can scale up and scale down, similarly like in a cloud. And we want to be able to give applications a value and processes. So we are from a system engineer, we are interested to know that MariaDB as a process is running, but from a business value, that doesn't make any sense. A business owner isn't interested if MariaDB is running or not. He's interested that, is my website available? Can customers order things on my e-commerce platform? And that's the difference between services and processes. Processes look more at things that is of value for the business and what they will use as KPIs for that. Most monitoring systems will have a notification and an alerting system. Typically, that is a pager that will go off, and a human will then log in and do work. But over time, we have seen that the work that we are actually doing is mostly the same thing. You log in, you want to make sure that the service comes up again at the point, because you're in the mindfulness of stress and getting everything up and running. You're not that interested to read logs and analyze why it happened. You're first interested to solve the problem, and then afterwards we could do a retrospect and see that. So it was a lot of information we had about problems that were actually things we could automate. And then we came up with the idea, why don't we do self-remediation and let the machines figure out if they can heal themselves, and if not, then a human can actually check that. Which is where Ansible comes in place. I don't know if everybody knows Ansible, but it's an configuration, remote execution orchestration tool. In our case, it has all the knowledge of the data centers. So it has all the information in its CMDB, which machines are running what, how they're running it, how they can scale up and how they can scale down. So it basically executes playbooks, which are roles that get executed and configure machines or configure services to be running again. We have Foreman, which is a lifecycle management tool, which is the more GUI version, which customers can log into and see what machines are running, how were they running, and it gives a nicer overview of the infrastructure itself. It integrates with all the tools, so it's easy. If you're using something else, you can still use this. And then we basically use the Icinga monitoring tool, and we abuse the notification and the execution of notifications. So in place of executing a command which will send an email, or executing a command which will send a pager request, we actually let it execute commands through Ansible to run playbooks. And those playbooks will actually be written in a way that they will do self-healing and self-remediation. So they talk to a Bastion machine, which then has all the knowledge and can then do all these interactions, which means that we as humans get disturbed less. It also means that if we see that a service is being overutilized, at that point we can actually provision more machines and allow it to have a bigger cluster. If we see that the load is less, we can actually scale down also. So the Icinga basically executes a playbook command, and that playbook will execute a whole bunch of roles. It will actually figure out if the VM is still there. If the VM is there, it will try to repair the cluster. If the VM has died, it will actually install a new VM, or it can even do a whole bunch of things on the load balancer. Sending some of the customers to another data center or to another location. So in a more holistic overview, you have the internet, you have your load balancers in front of there, and you have your web servers. You have your monitoring tool, which will be checking the web servers at specific time intervals, but also web servers can check in with the monitoring tool. So if a web server goes out, it will have a last will and testament, and it will actually say I'm rebooting or I'm dead because it hasn't checked in within a specific time interval. So let's say the web server 3 goes out here. It basically goes into a red state, a notification. Typically, the notification would be an email and a person would, or a pager, and somebody would have to look at it. In our case, it's basically Icinga who will get that. It will talk to the load balancer to take out the node that doesn't exist anymore first. It will then execute a task to the Ansible Bastion, which will then provision, in this case, 2 new machines. Once that provisioning has happened, they will actually check in with the Icinga monitoring tool, and Icinga will then decide that, okay, everything is okay, I'm getting the right return values, and then we'll add it back to the load balancer, and at this point we have new machines there. So for web servers, it takes about 10 minutes. It's not that long. It's building a machine from scratch. So building hold the VM, installing all the configuration, getting all the Redis data and everything distributed, everything. It's sometimes shorter, but typically we see 10 minutes. For a database, that's about 15 minutes because it needs to copy all the data there also. Similarly, for a database, in this case, let's say you lose 2 nodes and a third one becomes a higher load average. It can actually provision multiple machines again. It will talk to Ansible, which will then execute the new machines, and then it will create a new cluster. This allows the cluster to always be in quorum also. So if we see that actually one machine goes out, we'll provision 2 new ones just to make sure that we have enough quorum. Because if the machines go out of quorum, it goes into a read-only state, and so again, the front end will notice that. That has an impact for the business, and they don't like that, which means also we get called. So I hope that you understand that we can actually mix and match power. So for people who use it in a more system administration and from a perspective of data centers, even for many of the sysadmins we work with, we do tests, and we actually invite them to run their application on Power machines. In 99% of the cases, they don't even know that they're doing that. So if they're just a Linux administrator, most of them don't know that they're doing that. And for most of the open source tools, we can just rebuild them. You just have to recompile it, and it works 99% of the time. Here and there, patches. Yes, if you want to run it in a more optimized version, you need to understand the hardware better, of course. And that's where additional work can be done. But it means that you can already start moving people to Power and still keep them on their old platform, but not having to switch entirely.